Hello Longhorns, this is the review for Test 2 from the first 6 weeks of Algebra 2 pre-AP, and we're going to start with question number 2. Alright, for question 2 we are evaluating the absolute value expression we have here, and we're simply going to substitute in the values for B and C. B is -1 and C is 4. Into our expression and simplify. Alright, so you can see I have substituted in the -1 right here in for B, which is right here, and I substituted in the 4 where C is, so we have 4 squared. And now I'm going to simplify the fraction that's inside the absolute value bars, and that will be my next step. So when I simplify what I have inside my absolute value bars, this right here becomes 48 over -2. Now I'm going to take the absolute value of that. 48 divided by 2 is 24, and it's negative, so I'm going to take the absolute value, which would give me a positive 24. So when I take the absolute value of -24, I get 24, and so I multiply my -1/4 times 24, which then gives me a -6. So my final solution to this simplification is -6. Okay, the next problem we're going to do is number 4, where we are going to solve for n. Remember, when solving an absolute value equation, you want to get the absolute value part of the equation isolated before you start breaking it apart into its two separate equations. So the first step I'm going to do is multiply both sides of the equation by 3. This will allow me to eliminate this 3 that's in this denominator. Now that I have the absolute value part of the equation isolated, I can go ahead and break it out into its two separate equations, one for the positive value for n and one for the negative. Okay, so here are the two equations I'm going to solve. One is -7 plus 10n equals 45, and the other one is -7 plus 10n equals -45. After adding 7 to both sides, I have 10n equals 52 and 10n equals a -38. Now all I need to do is divide by 10. So my final answers are n equals 5.2 or n equals -3.8. So I could write these as decimals or fractions. So on the test you may see your answers written as decimals or fractions. If I were to reduce this fraction of 52 over 10, it would reduce to 26 over 5, and this fraction of -38 over 10 would reduce to -19 over 5. So you may see your solutions on the test as fractions or as decimals, so just make sure that you practice both. Alright, so the next problem we're going to do on this review video is number 9. Now, it may seem like, wow, Ms. Stiles, you sure are skipping a lot of problems from this review sheet. But remember, a lot of the problems on this review sheet are very similar, and we've given you multiple opportunities to practice. So it's up to you to practice and to work out all of the problems. And then if you have any questions about any of those that you have done on your own and you're not sure if they're correct, or if you want me to go over them with you in class, then we can bring that up during the review in class on Monday. Okay, just like when we were solving the equations, we're going to solve the inequalities the same way. We're going to isolate the absolute value expression before we break it out into its two parts. Alright, so the first step is to divide both sides of the inequality by -3. And if you remember the rules of dividing on an inequality problem, whenever you divide by a negative number, the inequality symbol flips to the other side. So not only are we dividing both sides by -3, the inequality symbol is going to flip when I rewrite my expression. All right, so now I have 4 minus 1/2 x is less than 8. So you'll notice that this negative number 24 here at the top, this number -24, has been divided by -3, which now makes this number positive. So that makes a big difference in our absolute value inequality solving, because now we don't have to worry about what happens if there's a negative here. All right, so now we're going to go ahead and finish solving by breaking this out into its two inequalities, one for a positive and one for a negative. All right, so you'll notice that I have written 4 minus 1/2 x, that's what's inside the absolute value symbols, is less than 8, which is what I have right here. Then the other expression is going to be 4 minus 1/2 x is greater than, we have to flip the sign, and we have to change the sign of the number to the opposite sign, which is here would be -8. So we've flipped the inequality over, and we've changed the sign of the number. Now we're ready to simplify both of these. All right, so you'll notice that the rule for adding and subtracting is not the same as for multiplying. If I'm adding or subtracting a negative number, if I'm subtracting a -4, for example, this does not make the sign flip. Only if I'm multiplying or dividing does the sign flip. Okay, so I've got an 8 minus 4 here gives me 4, and a -8 minus 4 gives me -12. Now I'm ready to finish simplifying by dividing both sides by a -1/2, which is the same thing as multiplying by a -2. So I can either divide by a -1/2 or multiply by its reciprocal. Now I like to use the rule of multiplying by the reciprocal because I think it's the easiest way to do this. All right, so something interesting happens here. When I multiply both sides by a -2, that eliminates this fraction here that we were trying to get rid of. But a couple of other things happen here. I have my x by itself now, but because I multiplied both sides by a negative, guess what happens? This inequality flips again. It flips over again, and this time I have x is greater than -8. On the other side here, after I eliminated the -1/2, I have a -12 times a -2. Again, the inequality flips because I'm multiplying by a -2, and this becomes a +24. So my solution is that x is greater than -8, but less than 24. So that would look like this. -8 is less than x is less than 24. And that would be the solution set for this particular absolute value inequality. All right, moving on to question 12. We have a factory produces cereal boxes that are supposed to be 12 inches high, but there is an acceptable margin of error of 0.1 inch. So how would we write an absolute value inequality that would match this problem situation? So the first thing we have to think about is, well, I know that the size of my box can be between 12 minus 0.1 and 12 plus 0.1. So since that can happen, I'm going to have something that's in between. And if I have something that's in between, then that's going to be a less than or equal to symbol. And I know that it has to be in between by 1.1 of an inch. So I'm going to put less than or equal to 0.1 here. Now for the absolute value inequality, I'm going to say that x, and then I need to figure out, well, I know that it's 12 inches high, so it's x 12. And for my operation in the middle here, I'm going to have to put a minus, because I'm going to have to add 12 on both of these inequality expressions. So if I'm just writing an equation for this particular problem situation, this word problem, this is what the inequality would look like. The absolute value of x minus 12 is less than or equal to 0.1. And that's all you need to do. Now, if I were to go ahead and solve for x, you'll see how this actually works. All right, so if I solved it, it would look like this. We would have an x minus 12 is less than or equal to 0.1, and an x minus 12 is greater than or equal to a negative 0.1. So when I solved for this one, I would get x is less than or equal to 12.1, and when I solved for this one, I would get x is greater than or equal to 11.9. So to write this solution set, it would look like this. 11.9 is less than or equal to x is less than or equal to 12.1. For problem 14, you are to list the transformations from the function y equals absolute value of x for each situation. So we're just going to do problem 14 in this case. And so I want you to look from left to right what each transformation is. We have several transformations. We have this transformation right here, which is the negative sign. We have this transformation right here, which is a stretch. We have this transformation here, which is a shift, and this transformation, which is also another shift. So from left to right, I'm reading my equation. So I'm going to start on the left, and then I'm going to list all of my transformations, and then we'll talk about each one. All right, so let's take a look at all these verbal descriptions that I have put down here, I've written down for this one equation. First of all, we have this negative sign, which is the vertical reflection over the x-axis. The next thing we have is a vertical stretch. So you'll notice it's vertical, vertical, outside the absolute value symbol, vertical. All of these transformations are vertical. This transformation is horizontal. So only the transformations inside the house are horizontal. All right, back to our stretch. We have a stretch of 4. Now, it's a stretch if this number is greater than 1. If this number is between 0 and 1, if it's a fraction, then it's a compression. That's how I remember which way we go. Fraction, compression. So this means that the graph would be compressed if it was a fraction or a shrink. But this is not a fraction, it's a whole number, and it's greater than 1, so this is going to be a stretch. The next thing I'm looking at is this horizontal shift. Now this is a shift, and you have to remember this little trick right here. This is actually minus a negative 8. So the real symbol right here should be a minus sign, but since it's minus a negative 8, we change that to a plus inside the equation. So since it's a negative 8 really, we have to say that the horizontal shift is to the left 8 units. This is a vertical shift. It's on the outside. There's no change in sign here. It's just down 1. So we're going to have a vertical shift down 1 unit. And that's it for these transformations. Okay, so for problem 16, you are required to write an equation for this graph. So this is a transformed absolute value graph. So we can start with the parent function, which is f of x equals the absolute value of x. And we can also sketch a graph of the parent function and then see how it's transformed into the new graph. All right, so I've graphed in the parent function f of x equals the absolute value of x, and really what I want to look at is where did the vertex go? Because that's going to tell me what my shifts are in my equation. So this graph shifted to the left 1, 2, 3, 4 units and down 1 unit. So the way I'm going to write that in my equation looks like this. All right, so far I have a shift to the left 4 units. So in my equation, I know that's a horizontal shift. So that's going to happen inside my absolute value symbol. So that happens right here. Now remember before what I said, minus a negative. So we actually have to write this as a +4 and not a -4. So don't forget that. That's real important to remember. Then the other shift we had was down 1. Well, that's a vertical shift. That's going to be on the outside. And since it's down 1, we keep the sign, which is minus and 1. So -1. Now we need to look to see if there are any other transformations. Well, this one looks narrower. This red one right here. This looks narrower than my parent function. So there must have been some kind of stretch or compression. So what I want to do is I want to look to see how far up and over I need to go before I get to my graph again. Now you'll notice in the parent function we go up 1, over 1. So we have what we could call a slope of 1. So let's see what happens with the red one. With this red graph, we're actually going down 1, 2, 3 units and over 1 before we get back to the graph again. So that means that I must have a stretch of 3. So I'm going to put that stretch right in front of my absolute value symbol to show that my absolute value is being stretched by 3 by showing that it's being multiplied by 3. Now I have one other transformation that's happening here. This graph is flipped. It's not upright like its parent function. It's upside down. So we know that when that happens, we must have a negative sign here that's causing this reflection. So our equation for this graph is going to be f of x is -3 times the absolute value of x plus 4 minus 1. Oops, I forgot my equal sign. Equals. And that's it. Okay, so in problem 18, we're to write an absolute value equation using the transformations that are given. So it's kind of like what we just did, except this is all verbal. So we're actually writing the equation from the verbal description. So first of all, I'm going to write down my f of x equals, and then I can start writing down what it has here. Well, there's a vertical reflection, so I know there's going to be a negative sign. There's a vertical compression by a factor of 1/3. So that's going to be a 1/3 compression. Then, since this is an absolute value, I'm going to use my absolute value symbols. And I have a horizontal shift left 8. Well, left means it's going -8. So x minus a -8 is the same as x plus 8. And then a vertical shift down 3. So my vertical shift down is going to be -3. And that's it. And we've written our equation. So you may have also noticed that we've used the word here compression instead of shrink. So sometimes you may see the word compression or sometimes you may see the word shrink. Those are synonymous, just so you know. All right, so let's take a look at problem 20. Here we have a table that contains coordinate pairs from a continuous absolute value function. Now, continuous means that it's not just these points. It's all these points and all the points that are connected to these points. So we're just going to use these points to help us form the graph. But then we're going to answer the question based on the fact that this is a continuous graph. Okay, so I've graphed these points, and since this is a continuous absolute value function, I have connected all the points with lines, and I have put arrows here at the ends. So this means that this graph is going to -infinity, and that's real important when we're trying to determine the domain and range. So the domain for this particular problem is going to be -infinity to +infinity, or all real numbers. The range, however, is coming from -infinity, but it stops. It stops at 2. So the range is from -infinity to 2, and 2 is closed. It's a closed point. So we would use a bracket around the 2. And that's it. All right, so in question 23, you're given 4 different inputs for this function. This is a piecewise function. That means that this is a graph that's broken into pieces, and each piece is a different function. And so we have one of the pieces is x to the third minus 7x if x is less than or equal to negative 3. We have that f of x is 8, which we know is a flat line or horizontal line at 8, when x is between negative 3 and is less than or equal to 3. And then the last part of the function is a square root function, the square root of 2x plus 3, where x is greater than 3. So it depends on what number you're given right here. You have to look to see what your input is and which case it fits into. So for our first evaluation, we have that our input is negative 5. We'll have to look over here to see, well, where is negative 5 in my function? So it's not in between negative 3 and 3, and it's certainly not greater than 3, but I know that it is less than or equal to negative 3. That means that I'm going to use this equation to evaluate this value for x. All right, so when I plug it in, I plug in my negative 5 into only this equation, not all of them, because it doesn't fit in all of them. It only fits into this one. I plug it in and I get that my y value is going to be negative 90 for that input of negative 5. So for a problem like this, that's all you really need to do. You need to look to see which part of the graph your input fits into first, and then use that equation to simplify. All right, so the next problem, we have to write a piecewise function and its domain for the given graph. So here I'm given a graph, and so the key to writing these equations is to find the equations of each line. So I'm going to find the equation of each line, and then I can put it together as a piecewise function. So here you can see that I've extended out this graph. It actually stops right here, and that's real important to know. But to get the equation of the graph, sometimes I have to go ahead and extend it out to what it would have been before we restricted the domain. So I go ahead and I fill that in just so that I can try to figure out what the equation should have been or is. So I'm going to go ahead and make this a dotted line so you know that it's really not part of our graph. I'm just putting it in there to help me figure out what the equation should be. So I see that this line crosses this y-axis right here. Well, that's real important because I need that point to write my equation. So I know the equation for this line, it has a negative slope, and I know that it has a negative slope of 1 because this graph has a scale of 2. So I'm going over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. So I know that my slope is 1, and I know my slope is negative. So far for my equation for this line, I have that f of x is equal to negative x, and then I know my y-intercept is negative 1, so minus 1. So this would be the equation for this line here. Now for the next line, I don't need to do all that. For this line here, it already crosses the y-axis right here at 0. So I know that the y-intercept is 0. So really all I need to find is the slope. Well, this graph goes up 4 over 2, which is a slope of 2. So I'm going to use my slope of 2, and I'm going to write that this graph is 2x, and I don't have a y-intercept except for 0, so I'm not going to write plus 0 on the end because I don't need to. So this is the second part of my function. So the equation for this first line that we found was this negative x minus 1, and then the equation for this line is going to be 2x. Now I need to identify the domains for each one. This one's domain begins and includes negative 3. So I'm going to write that This line exists everywhere where x is -3 or less than -3. So I would write where x is less than or equal to -3. For this other line, though, it begins at -3 also, but it doesn't include it, and all of its points are greater than -3. So the way we would write that is just x is greater than -3. And so this is our piecewise function, and this is how you would write the equation for it. All right, so this is the last example I'm going to give you for this video review, and this is graphing the transformations of a given piecewise function. So you might be given any shape. In this case, we're given kind of a zigzaggy shape. So the first thing you want to do is jot down your points for your parent function, and then we're going to write a table for our piecewise function that's transformed and then graph it. Okay, so the first thing we do is create a table for our parent function, f of x, and I'm just using these main points of -5, 2, -3, 0, -1, 2, 1, -2, and 3, -2. And then we're going to perform these transformations right here on this table, and then we're going to graph that. So we want to take care of all of these vertical transformations and the horizontal transformations separate. So these horizontal transformations, this is the only thing that's happening to x. So if I don't have anything inside here, then there's nothing happening to x. These values would stay the same. But since I am moving this graph to the left 2 units, I need to subtract 2 from each one of these numbers. Now this says +2, and I know you're thinking, I just can't get this, Miss Stiles. I don't understand why it's subtracting 2 when it says +2. Well, remember, this is actually minus a -2, okay? And that's why we write +2 inside the equation, but it's really x minus a -2. So we're actually going back 2. So we subtract 2 from each one of our x values. All right, so when I subtract 2 from all my x values, I get -7, -5, -7, -5, -3, -1, and 1. Now I need to take care of all my vertical transformations. And I'm going to do multiply and then subtract, just like we do in PEMDAS. You're going to multiply first and then subtract. So I'm going to multiply all my values here by 1/2, and then I'm going to subtract 3. Okay, so I have multiplied all of these numbers by 1/2, which is basically just cutting them in half. So half of 2 is 1, 1 minus 3 is -2, and so forth. And I've come up with these values for y. Now I'm going to graph these points. All right, so I've graphed my points and I've connected my dots, and you can see that this graph looks similar to the parent function, except it's not as long, so it's compressed, which is what the 1/2 here did. The 1/2 caused this compression. Remember, fraction causes a compression, and so this is a compressed graph of this. It's also shifted to the left 2 units and down 3. So you can see how this transformation turns out once we apply all of these different transformations to this parent function. Now that's the last example I'm going to give on this review. I do expect you to complete all of the review and make sure that you practice every problem, and please bring your questions to class on Monday so that we can go over anything that you may not be completely understanding, so we can clear that up before the test on Tuesday. So good luck on your test on Tuesday, and please come to tutorials if you're needing additional help.